So I'm really excited. I had this really puny demo as of this morning, and about an hour ago, right after lunch, me and Oliver McFadden were chatting about Dante, and I had this great idea. Oliver, will you help me rewrite my demo to be Dante? And we finished it about less than 2 minutes ago and got it finished. So I definitely neglected the end of my presentation notes for the sake of demo, so we'll see what happens at the end. So I'm Chad Versace. I'm from the Intel Linux graphics team, and I'm here to talk about Waffle, which is a library we are currently using to solve some problems inside of Piglet, which is used for testing Mesa. And Waffle is also useful outside of Piglet, and we'll get to there. So first I wanted to discuss why I needed Waffle, and that starts in the problems we had in testing Mesa. So I'm going to talk about Piglet for a minute before moving on to talking about Waffle itself. So for anyone who doesn't know, Piglet is Mesa's test suite for OpenGL, OpenCL, EGL, and GLX. And for this talk, we're just going to restrict our attention to the OpenGL test. And the problem that we had that necessitated Waffle's creation is Piglet uses Glut for its platform abstraction layer. And Glut is old, and it's venerable, and it's no longer sufficient for what Piglet needs to do. On Linux, Glut supports only interacting through GLX. It only supports creating desktop legacy GL contacts. And the unwelcome consequences of this is that we're trying to support OpenGL 3.1 core profiles in Mesa right now, and it's impossible to create a core profile through Glut. It's impossible to even request a particular GL version through Glut. So you're stuck with just legacy compatible context when using Glut. And the other thing is that Glut doesn't support the creation of OpenGL ES context. And OpenGL ES is becoming more and more important. But because we're using Glut, we have to resort to ugly hacks inside of Piglet to create ES test, which means there's this many when, there's probably only a dozen right now at the max, and we should really have a vast quantity of ES tests considering how important it is. Oh, another thing is Piglet only runs on GLX, therefore the EGL code paths don't get exercised very much, and Piglet's not going to run on Wayland or Android because it's confined by Glut. Another problem is glue, but I guess we can skip that and come back to that if we have time. So let me turn on word wrap. Okay, sorry about that. There. So we need a solution, and we have to replace Glut with something better. And we wanted that something better to have things that Glut doesn't have at all. One of those things that if we require a developer to build Piglet multiple times for multiple Windows systems, the developer is not going to build Piglet multiple times. The developer is only going to build Piglet once for GLX and run test under GLX, and that's all they're ever going to do. So we wanted to have a Glut-like solution that can run on any Linux Windows system, GLX, X with EGL, or Wayland, and we want to be able to do that decision dynamically at runtime. So we build the entire test suite once, and then choose via some environment variables to which one to run underneath. And we also want to be able to build a test once and multiplex it over all possible GL APIs for which that test is applicable. So for a large subset of tests, the test should work under OpenGL ES2, OpenGL ES3, or desktop GL. It doesn't really matter. And we want to be able to test all those paths. And one way to do that is to dynamically choose the GL API at runtime, and which is difficult. We're still working on that. And that's an interesting concept because I'm not aware of any projects that have attempted to do that before. And our plans there are to replace glue with this dynamic dispatch mechanism. But that's really outside of the scope of what Waffle does right now, so I'll just come back to that if we have time. Another quality of this ideal solution is that it's not inside of Piglet. We want to be able to generalize it and write it in an independent fashion so it could benefit projects other than Piglet. So right now we have some The Intel team is using API Trace. If you've heard of that, it's a tool that allows us to record the stream of GL API calls made by programs, allows us to replay them later for performance measurements or for debugging. And it would be nice to use the same library to capture a trace on one Windows system and play it back on Wayland per se, or play it back on Android per se, and do other things. Or if you need to write a really quick standalone test that's outside of Piglet, because if you may not necessarily care about Piglet, and you care about this test running under GLX and EGL and Wayland, then it'd be nice just to hook into this, into Waffle, and be able to do it that way instead of building your test inside of Piglet. So the status of what we are right now and solving these problems inside of Piglet is that one is complete. We're able to dynamically choose the window system platform at runtime using glib_waffle. Number two, dispatching to GL API at runtime is more difficult, and that's still under development. And we have preliminary support for that inside of Piglet. It needs more infrastructure, and the plan is to eventually move that to Waffle when it's complete. But a lot more work needs to be done there. So in Piglet, there still isn't support for running tests against GL core profiles. I'm working on that right now. That should arrive mid-October. So in Piglet, using Waffle, we can dynamically choose Windows system, but we can't write GL core test yet, by no fault of Waffle, just because the extra infrastructure is needed in Piglet right now. So let's talk about Waffle for a minute. Waffle is a cross-platform C library that allows GL applications to defer its choice of Windows system until runtime, like the abstract says. Its API is really straightforward. It resembles EGL with some additional functions for creating a window, mapping the window to the screen. It contains some additional functions to allow you to DL open and DL sim your libgl, rather that libgl be desktop GL, GLUS1, GLUS2, and these functions abstract away from your underlying operating system because these libraries have different names on Mac OS, they have different names on Linux, and the functions abstract away from that. And interestingly, unlike GLUT, Waffle allows you to get at the native underlying objects of the created window, of the GL context, of your X display or Wayland display. Using Waffle calls, you can get back pointers to those native objects, so you can implement behavior that your application may need that's outside of Waffle's scope that Waffle may not necessarily implement. So for example, Piglet uses this ability to implement input for Windows, even though Waffle itself doesn't support input. After Piglet creates the Waffle window, Waffle GL context, and sets everything up on the screen, and then grabs those native pointers and intercepts the input itself. So right now, the supported platforms in Waffle is Linux. All the Windows systems in Linux are supported right now. There is Android support in Master. It's experimental. Kind of works. Looks like there's some bugs in the Android system itself that we're working around right now. There is support for Apple basic sanity test work. We haven't run Piglet on Apple yet using Waffle, so I'm leaving that experimental, though we haven't actually found any bugs yet. It just hasn't been used enough to say that it's stable. We want Windows support eventually, but I don't know anything about Microsoft Windows, so patches welcome. So wanted to give you a quick demo, and then quickly talk about the focus of Waffle, what its intended purpose is. It's not a general purpose library, and then maybe look at the API very quickly so you can see if it's applicable to anything you may want to do. So about an hour ago, I contacted Oliver. We've been hacking in the back really, really hard. After about 30 minutes, we got this up and running, where we've taken Dante's, I don't know if anybody wasn't here the very first day, Oliver McFadden at Intel has ported the Doom 3 engine to EGL and GLUS2, and In the last half hour, we've pulled out the EGL backend and replaced it with a Waffle backend. So now using Waffle, we can dynamically choose with the environment variable. I don't know, it's probably too low for everybody else to see. So let me, yeah. So by setting environment variable that the Dante platform should be X with EGL, we can run Dante like the way it normally runs with Glass 2 and EGL. And if we fire up the Wayland compositor here, and we set the environment variable instead to Wayland and run Dante again, the same binary. We've only built Dante once. The same game runs under Wayland without any rebuild or recompiles. And the glue level is very, very, very thin. After, when me and Oliver took the original EGL backend, of course I'm killing the frame rate. I'm running the game twice simultaneously. So when Oliver and I was working on replacing the EGL backend with the Waffle backend, we actually found out that the Waffle backend took about 2/3 the amount of code that's in the EGL backend. So even though Waffle is an abstraction layer and it's glue code, it's actually really compact. It's more compact than if you have used X11 and EGL directly. So how am I doing on time? 20 minutes. Okay, I went too fast. So I wanted to look at the API real quick, just to show you what it looks like and show you that it's really easy to use, and then open up for questions. Oh, I wanted to talk about the purpose of Waffle. So this is where I stopped working on the presentation and started working on the demo. So Waffle is not GLUT, it's not SDL, that's not its focus. Waffle will not support input, it won't support audio like SDL does. The purpose for Waffle is to, if you have a demo application, or if you have a small application or a test, and you want to quickly bring it up on multiple Windows systems, if you want to make sure your test works on Android, Apple, and various Linux Windows systems, Waffle is good for that and good for demo applications. You could write a real application with input and everything else that comes with that with Waffle, but you would have to implement that yourself on top of Waffle. And Waffle makes it easy to do that, but it's not its purpose to supply that need. So wanted to look at some example code real quick, so you just see what the API looks like. So if you go to example code, there's a very simple example where down here, Waffle is, the way inside of Dante we dynamically chose the Windows system platform is that we read that environment variable, Dante platform, and this enum here we switched out based on environment variable. If you want to run Waffle underneath Wayland, you switch this enum to Waffle platform Wayland instead, and then when you call Waffle init right here, that chooses if you want X or Wayland just based on that enum. So it's really easy to do the dynamic dispatch from the application side. Here's a attribute list, which is really similar to a EGL or a GL attribute list. And you see that you can choose the context type here inside the config and the red, blue, and green size just as you would when choosing a GLXFB config or EGL config. The API really closely resembles GLX and EGL because that's what people are accustomed to. And then down here, choose a config, create a window, create a context, map the window to the screen, and make everything current. Start rendering, swap your buffers. So it's a minimal API, it's really straightforward to use. It's well documented inside the headers. All documentation is inside the headers. So other than that, one other thing is if you wish to get at the underlying native objects, here's an example where we've initialized Waffle with X and EGL, and after you create the window, there's a get native function here that allows you to get at the native window and then extract the xlib display, the EGL display, xlib window, and EGL surface outside of that Waffle object. So you can't create Waffle objects by wrapping native objects. For example, if you already have an EGL display, you can't create a Waffle display out of that. Might add that feature in the future. Right now, you can only get things out, so you must create the object first with Waffle. And that's everything. Is there any questions?
So I noticed that you had in that demo app a bunch of DLC calls and gave your function pointers out of the GL library.
Yes.
Have you thought about doing some sort of wrapper header that would get those in?
Yes, the idea is similar to what we're doing in Piglet right now. So in Piglet, we don't use glue anymore. Instead, we have some macros for every GL call. GL clear is now a macro. Every GL call is a macro. And this macro dispatches to a function that does the DLSim for that function name if the DLSim has not occurred yet, and then returns it then sets some function pointer appropriately. So the DLSimming is done when you first call the function, not at application initialization time. And I want to add that to Waffle for all the GL APIs. I want to be able to do that for desktop GL, ES1, ES2, ES3, and somehow have, there's a lot of work to do still. But that's in the plans. So what else is in the plans is, right now there's a patch series that is looking really good. I haven't merged it yet. It needs to undergo a little bit more review, where we add a KMS backend for Waffle using libgbm that Christian spoke about yesterday. And once we add the KMS GBM backend to Waffle, it'll be possible to run the entire Piglet test suite, the GL test inside of Piglet, on top of KMS, which means you can do it on a headless server. This is important for some distros because their test labs, their QA infrastructure uses headless servers, and they are wary of pulling Mesa patches and updating their package because they can't effectively run Piglet on their QA infrastructure because of the headless server issue. So once we get the GBM backend inside of Waffle, Piglet will be able to run inside those QA infrastructure. Another unexpected benefit of having a GBM backend is that on the Intel Linux team, we often get new hardware that doesn't work. and the people who are on the kernel team who are bringing up the display sometimes are having trouble because display is difficult to bring up. And sometimes the 3D part of the hardware is brought up in the kernel driver before the display is brought up. And we've had a situation with some recent hardware where we really, really wanted to test. We wanted to run Piglet on the hardware and run some 3D test, but we were incapable of doing that because we were blocked for several weeks on the kernel developers bringing up the display. And now with the GBM backend inside of Waffle, we would be able to run those 3D tests and begin debugging Mesa immediately without the display folks being finished with their job in streamlined development. Yes? About what? Okay, so right now, let me show you what it looks like inside the example code, and that's not what it's going to look like forever. Right here, I'm not including any GL headers in this example code. I'm defining GL clamp, GL bit filled, the necessary enums here at the top of the file with the appropriate function pointers for GL clear color. So I'm doing a baby dispatch inside this example file. And down here, I'm Waffle DL-simming the OpenGL ES2 library for GL clear color and assigning the function pointer that way. And this API is structured this way so it can be cross-platform. On Mac OS, the library has a different name. On Mac OS,
no, but I mean, what if you have, like, your example game and you don't know in advance whether it's valent or not?
I can show you, because we just wrote that code. It's like 6 lines of code. Oops, that was right there. Neo, Linux, sys. So quickly to jump back, this is how we started. Oops, this is how we started Dante with Wayland by setting that environment variable. And if you go to the file responsible for that inside of Dante, this is the code we wrote about half an hour ago. We first read the environment variable. We set this platform enum to 0. If the environment variable is x11egl, we set the platform enum to be x11egl. Same for Wayland. And then here we set up the attribute list so that Waffle platform is the chosen platform. And we call Waffle init. That's all you need to dynamically dispatch to a new Windows system.
Yeah, but I know. What if you don't know it in advance, for example? Just set by the user without any arguments.
Well, you can choose a default system inside the file right here. For example, if the environment variable wasn't set, we could have chosen GOX as default.
So there's no code to do it for you?
No, because Waffle's not going to make that assumption on what your application needs.
Okay.
But it seems like a lot of applications will need sort of the same thing. Like you could imagine common heuristics like if the display environment variable is set, then okay, I want to use X and then try to decide something from there. So it might make sense for Waffle to have a another enum value that says pick for me, and then there'd be some heuristics. Yeah. Yeah.
But it's very simple. Instead of having just a Waffle platform, please choose for me environment variable, we might have different enums defined for a different heuristic.
Yeah.
And we can have a heuristic that accommodates that situation.
Yeah.
It's a good idea.
Yeah, just so that not every app, otherwise apps are all going to try to have similar things and then decide in different ways and be inconsistent. Yeah. And then one unrelated thing, the Waffle DL-Sim, so it sounded like the implementation of that calls DL-Sim?
It just calls DL-Sim in the background.
Okay.
And before you call DL-Sim, if you look right here, there is a function here where we, I'm not calling it here because this example is very, very simple, but there's another function that says, Waffle, can I DL open this library on the system? And it'll return true or false so you don't go down. Am I using it where? Oh, DL can open. There it is. Okay. And there's also this enum variable here which checks first if the Wayland display or the X display, whatever, is even capable of constructing a context of your desired type. And it inspects various extension strings exposed in libraries installed to make that decision.
Okay. It may be worth considering in in the implementation of Waffle DL-Sim to use get proc address from the Windows system that Waffle selected.
Oh.
Because technically, according to at least the current Linux OpenGL API, the symbol isn't guaranteed to be there. You're only guaranteed to be able to get it through get proc address.
So there's a very fine point there where these symbols exposed here are guaranteed because they exist in a GL version that's old enough.
Okay, fair
But
enough.
on the other hand, there is a Waffle get proc address that is backed by EGL get proc address or GLX proc address or CGL get proc address. And the problem is, whenever I start incorporating the dynamic GL dispatch system inside of Waffle, it'll detect your platform because these rules are different for Windows and for Linux and for Android and for GLES2 or for GL. And it'll try to heuristically use get proc address or DL-Sim accordingly based on platform. So right now, you think DL-Sim should call get proc address
We should get GLX get proc address or EGL get proc address.
Okay.
And I'd have to check in the spec if the symbols that are required by the ABI are also required to be delivered through GLX get proc address. I think they are. Sorry.
The rules for EGL and CGL were weird. So
yeah. So for GLX, yes, any symbol that you make available, get proc address can give you. For EGL, it's up to the implementation because for tiny little embedded platforms, they didn't want to require them to have this kind of redundant string table and stuff. So it's, maybe.
So I was afraid of these fine nuances among different platforms. So as a first pass, I made DLSIM use DLSIM and get proc address use get proc address, and allow the application or the client code make the decision which one to use. So maybe when we resolve all those issues, we can do that intelligently inside of Waffle.
What you could do is on those platforms for like EGL, you could try calling EGL get proc address, and if it returns null, then try DLSIM, and if that fails, then, well, you're just screwed. So
that's an idea.
To go on about get proc address, because we love get proc address. Isn't it the case that for GLX, the get proc address result is context dependent, or was that Windows? One of the two. Yeah, for Windows, it's context dependent.
I'm not writing the Windows backend because I'm afraid of it. I wasn't aware.
It does seem like we will need specific dispatch code that can handle, actually choosing to do get proc address versus returning a current function pointer based on which context is currently bound and
when
despair.
when we get to that point, we'll also have to rev the Waffle ABI because get proc address is context independent right now.
Yeah.
The function call is context independent.
So on Windows, it's even uglier than context dependent. It's dependent on your pixel format. So if you make 12 contexts and they all have the same pixel format, the function pointers will be the same. If you make one that's a different pixel format, it's going to have different functions, because Microsoft's original software rasterizer would dynamically generate different code depending on your pixel format, and we'll just return that directly. Strong work, guys.
Okay, so much testing will be needed when the Windows backend arrives. Are there any other questions, suggestions, comments? Okay, thanks for listening.